Hi, so we're going to talk now about how to insert at a position into an array-based list. So what I have here is an array. We're going to treat it as a list. Remember, a list is a data set that is stored in a sequence. And in order to store a list into an array, we need to be able to insert and maintain that sequence. So I'm going to give a couple of quick examples of how this would look, and then we'll write some code. So right now my list is empty, and if we wanted somebody to insert into it, then the only place they would be able to insert is at element 0, because we want to anchor our contiguous sequence at the top. That's the easiest place to do it. So if somebody was to insert a number at position 0, then it would simply go into there and we would increment size to 1. No problem. Now, if we wanted to insert another item into this list, in order to keep the sequence contiguous, meaning together, we would only be allowed to insert at position 0 or position 1. This would be adding on to the end of the list. So if someone wanted to insert at position 1, fine. We would just add an item there like 7, and then we would increment our size. And this would be no big deal. As long as we were continuously adding onto the end of the list, all we do is put the item at the end and we increment size, no problem. If the list is ever full, then we can't do that anymore, assuming we have a static array-based list. We'll talk more about dynamic array-based lists a little bit later, but for now we're assuming that arrays have a fixed size. Now, if somebody wanted to insert here, we could have an insert at 0, 1, or 2, and we would still have a contiguous list. So we have 3 possible positions now. If somebody wanted to insert, say, at position 1, then we could do that, but we would have to get the 7 out of the way because we want to put the new item there. And the only place for the 7 to go is down here. So we need to move the 7 down, and by copying it down, we make room for our new number, whatever that happens to be. Let's just say 8. And then, of course, we would increment our size every time we insert. So the insert at operation, which is where you insert an element at a position, right? That has a range that we need to make sure we validate. When they give us a position, we have to make sure it's in a certain range. Otherwise, our list will be non-contiguous and then not be a list anymore. And we need to shift everything down in order to make room for it if we're not putting it onto the end of the list. So let's write a little bit up here to describe what we need. First of all, when somebody calls this method, they need to provide us with a value, which we will call item. So that's whatever they want to insert. And they also need to give us a position. These are the 2 things that we have to know. When we know these things, then we're good. In order to pull this method off, we have to go through a few steps. The first step, and always this must be the first step, is we must validate the position. If we don't validate the position before we use it, who knows where it is? We're going to take this position as an integer. Well, it could be a negative integer, which is out of range. It's not even in the array. Or it could be a value that's not in our block where inserts are valid, in which case it would mess up our list. So we must first validate position. That's our first step. The second step is to validate one other thing. If the list is full, then we can't insert because there's no room. Arrays are fixed in memory. Once you declare an array, you say, I want a new array, and you give it a size. It's put in RAM, and it's not going to change size. You can't just make it bigger, because what will you make it bigger on top of? For example, if you live in an apartment, the space for expanding your apartment doesn't exist. You can't just say, I want my apartment to be 10 feet bigger, because you have to go into somebody else's apartment to do that. Likewise, if you have an array in RAM and you say, I just want it to be bigger, well, who knows what you would be marking over to make it bigger, so you can't make it bigger. Interestingly enough, you can't make it smaller either. If you try to make it smaller, right, you can say to yourself, well, I want my apartment to be smaller, and okay, you could probably do that, but what would happen to the leftover space? It's just sitting there in this really awkward way. So it turns out that memory managers don't allow you to shrink arrays because it's too difficult to keep up with. It's just a pain in the neck for a memory manager to deal with that. So if you want to change the size of an array, you have to make a new array of the size that you want and migrate all of your existing data into that array. That's how resizing is actually done. And when we get to dynamic arrays, we'll talk about that. That's a later issue. So we have to validate our position, and in our standard array-based list, our static array-based list, we have to make sure that we are not full. And I just wrote if instead of is full, right? We need to make sure that we are not full. Okay. If these two things are correct, then we're ready to go. We can move on. Now, in order to move on, we need to make room. So the next thing that we have to do is shift elements down until the position we want is vacant. All right, it's not technically vacant, but it's going to have data in it that we no longer care about, so that's effectively vacant. Now, in order to do that, we need to loop and migrate up from the end of the list. So this is the next thing we want to do, is we want to shift elements to make room. For item. All right, we need to do that. Now, once we've done that, our job's almost done. We need to insert item, put item into position. And I love to misspell position. Once we've done that, we're almost done. We need to increment size. We cannot forget to do that. So those are our kind of boxed lists, if you will. So now what we want to do is we want to do this insert at, and we want to take our item in position, validate that our insert is going to work. When we know it's going to work, then we can move items out of the way. We can put the item in place, increment size, and our insert will have worked correctly. So now what I'm going to do is I'm going to switch to NetBeans. And so give me a second to share the screen. And so now we're in NetBeans. You might recognize this ArrayList class. It's very close to the one that I copied up onto Moodle for everyone. But here I have my insert an element at a given position. And so let's go ahead and start making this. First, I very clearly want this to be a public method, and I don't want it to be static. So I'm going to leave off static, of course. I want it to work on every ArrayList object, not just the class. And it looks like I've got it slightly off, so let's fix that. And now, here's another thing that I want to do. I want to report success or failure of this operation. So in order to do that, I have several options. We've gone over them in class. You can throw exceptions. You can use an assert statement. You can do nothing. You can just not insert and then do nothing else, just sort of block it. Whatever you choose, you need to encapsulate this operation. You need to make sure that this operation does not mess up the data structure. It does not mess up your list. Now, what I like to do, because it's really simple, is I like to return Booleans. This is just one of many options, but by returning a Boolean, someone can use the insert at. They can put that operation in a Boolean expression and see if it worked. And if it failed, they can try to figure out why using their own code. And if it worked, they can detect that it worked and move on. So it's a pretty simple, direct way of encapsulating a method that modifies the data set that it's in. And of course, I'm going to call it insert at, and I'm going to take an int called item, spell it right, and an int called position. Okay, and spell that right. And then I'm going to hit this. I don't know why it's hesitated for a while. But the very first thing I'm going to do now is I'm going to validate all of my data. So the first thing I'm going to validate is position itself. So is position less than 0? What I'm doing here is I'm checking for bad values. If position is bad, then I can't do my operation. So I'm going to see if it's less than 0, well, that's bad. Or is position greater than size? All right, size is the variable that I'm keeping track of that tells me how many there are. Now, here's the thing. Size is 3, which is empty. Okay? The range of your list is always element 0 to size -1. That's the range of indices that store items in the list. But I can insert into position size because that would simply be adding something onto the end of the list. So my valid range is 0 to size for inserts. So if anything is lower than position or greater than size, then it's out of range. And then finally, I need to make sure that my list is not full. If, and I have a method right here, you can see is full. I'm just going to go ahead and use that. If my thing is full, all 3 of these are situations that would prevent me from inserting. So I will return false and just bail out and tell somebody this didn't work. And I'll let them sort out why it didn't work. I don't want to write a message and say, you gave me a bad position, enter a new position. That is completely wrong in this environment. Because in this environment, nobody can answer that question, right? You don't know who the user is. You're talking to the programmer, not the user. So we're just going to return false, and the programmer will have to cope with that on their, just the way you cope with it when you make errors. Now, one little trick that I like to do is I like to get NetBeans to stop telling me that not all of my paths are returning. So I'm just going to type return true, because if everything works, that will be the answer. And that just gets NetBeans to stop sort of annoying me with an error message that I'm going to fix later anyway. Okay, so I've done validation. Now I'm ready to do the shifting. The shifting is the hard part of this operation. This is the situation where you really have to worry about off by 1 errors. We're going to be moving things down, and we're going to be going up, and we're going to be starting at the right spot. And if anywhere along the way we get our index off by 1, the whole operation will fail. And so we don't want that to happen. So we need to really carefully consider what we're doing at this point. So here's what I know. I know that position is valid. And I know that my list is not full. Because I know those things, I can make certain assumptions. I can make the assumption that size is empty. The spot at position size is available for me to put data in. I can make that assumption now. So this is what I'm going to do. I'm going to start right there. And so long as I am so long as I am greater than the place I want to be, right, then I will grab the item above and move it down. And then I will move myself up. So that's the technique that I'm going to use. I'm going to start here, look up, move down, jack up, look up, move down, go up, look up, move down until I either hit the top or until I hit position. By the way, I'll never hit the top. I will always hit position because I know position is between 0 and size. That's guaranteed because I've already checked. So this is what I'm going to do. I'm going to declare an int, right? I'm going to call it current position, right? And I'm going to set it equal to size. So that's right here. And now I'm going to do a little while loop, right? So long as current position is greater than the position that the user gave me, right? So long as that is true, then I know that my current position hasn't moved up enough. So I need to move it up. So in order to do that, before I move my current position up, I need to grab the item and move it down. So let's do that. So I need to say that array, this is my array here, private int r is the thing that's holding my list. So r at current position, this is where I am, right, will be set equal to the element just above me, current position -1. And here's the thing. I know that I'm not going off the top of my list because position has to be 0 or bigger. And if I was at position, I wouldn't be in this loop because my while loop would have triggered. And so I copy the item down and then I adjust current position up, and I spell it right, by subtracting 1 from it. And this will cause me to shift up while grabbing items and moving them down. Now, by the time I hit position, one thing is guaranteed to be true. That space, whichever one of these it is, will be ready for me to put item into it. That will be true because I have moved the item down out of the way, or I'm at the size which is empty to begin with. So what I can do now that I've shifted, is I can put the item down, and so I can say R at either position or current position. By now they are equal. Position, that equals item, right? And then I don't want to forget to increment size. If I don't increment size, then I'm in deep trouble because my size will never change and it won't be a list properly. And so now I've got what looks pretty good. Of course, you know that I never trust my code until I've tested it. And even then, I'm nervous unless I've thoroughly tested it. So let's go into my driver here. I made this before, sort of like a baking show. Here's something I prepared earlier. And basically what I have here is an array list that I instantiate. It's going to start off at 0 size, and I've got 2 ints, item and position. And I'm just going to run this indefinitely. I'm just going to run until I'm tired of running it, just to test it. And so it basically, I insert an item and I insert a position, and I try to insert it, and then I print my list. So let's run this file. And so the item, let's just put in a 45, it doesn't matter. Now in this situation, the only valid possible space is 0. Why is this true? Because if I type a negative number, that's automatically out of range. If I type 1 or more, like if I put in my position index 1 or position 5 or position anything greater than 0, well, then that's not going to pass my test either, right? It's got to be greater than 0, and it's got to be less than or equal to size. And it has to not be full. Well, it's empty, it's not full. So in this situation, when I type in my position, I can try something else like 5 and nothing happens. I can try something like -4 and my Boolean expression is kicking in and denying. So now I'll do position 0, right? And it inserts, right? Oh, I typed in item as -4. That's pretty silly. So I messed up my own code. But the item was -4 and position was 0 and it worked. So now let's do another item, 56. And now I can do either position 0 or position 1. Let's do position 0. And this should insert the 56 in front of the 4. And it did. And now I'll do item 25. And let's insert this at position 2. This is position size. So I should tack this on to the end of the list. 56 minus 4 and 25 should be what it is when I'm done. But I have to type in the 2, right? And now let's do another item, 1, 2, 3, 5. And let's put this, my valid range is now 0 to 3. I have 4 possibilities here. And let's just put this at position 1. That's going to scoot the 4 and the 25 out of the way. And you notice how this is just continually inserting 5. And now let's do position 0. This would be at the front of the list, moving everything down. And I can do another one, 84. And I can do this. There's 5 in the list, so the size is 5. I should be able to add this to position 5, and this will tack it on to the end of the list. All right, so the 84 is on the end of the list. So that is how you implement the insert at and why you implement it the way that I've implemented it. Now, there are several other ways to write this. I used a while loop. Some people use for loops. Some people increment size first and go from there. It doesn't really matter. The point is you need to make sure that your position is valid, your list is not full, that you shift elements to make room, that you put the item in the correct position, and that you increment size. Very clearly, these two have to be done in this order, but sometimes you can put size up here. You better validate first. It just depends on how you want to set it up. But that's the insert at, and it's a very, very important algorithm to know, because if you know how to insert at a valid position into an array-based list, then you understand a lot of fundamental items about data structures, how to keep a data structure correct. Let me stop my share so I can talk. So how to keep a data structure intact, right? How to add to a list without breaking it. That's not only encapsulation in terms of object-oriented programming, that's just keeping a data structure valid. And it doesn't matter what the data structure is. If you understand how to create an array-based list and keep it valid, then you've learned a very powerful lesson. And the details of why these things are set up the way they are, it's very crucial. So we have from concept to algorithmic analysis and sort of the design, all the way to the code that I showed you for the implementation and why it's implemented, and even a little bit of testing. So I hope you understand this, and the next video will be the remove at. And so I'll see you then.